Okay, heat equation. It's a partial differential equation. So we have u t equals to something times uxx. So for this example, let's try to put 3. I'm just putting some random numbers. And then we're going to say that the boundary, I'm picturing this rod with length 2 meters. So length is 2. And the endpoints are touching ice so that the temperature is always 0 Celsius. So I'm going to assume that U of 0T and U of 2T is set to 0 for all time. This is for all time and also x. No, that's it. That's for all time. And then I also have to tell you what the initial state of the rod was, because if you don't know what it was in the beginning, then there's no way there's no way to find out what happens afterwards, right? So the initial state of the temperature distribution is when time t is equal to 0. Let's just have something like, let's just keep it simple because this is our first example, okay? So let's just say it's 4 degrees Celsius. So it's uniform temperature in the beginning, it touches ice, and then soon afterwards the endpoints will decrease. Alright, so let's try to solve this. So when you solved just the regular differential equations, the ordinary differential equations, one of the things that you did was to first try to find all the solutions of the given differential equation and then apply these endpoints to figure out what these coefficients should be, right? So something similar happens in this case. So first what you want to do is you want to find some generic solution of the differential equations given, and then only after figuring that out you want to apply these. But even that, it's kind of hard trying to find out the generic solution of this. So what you do is to think about solutions that look like a function of x, let's just say f of x, and a function of t. So that's what I'll do. I'll try to find all the solutions that look like a product of a function of x and a function of t, and then hopefully from that we may be able to add these up, take the superposition of these individual solutions with some coefficients, and maybe from there we can get the generic solution. Right? So you know the principle, we don't solve differential equation, we make guesses, and we don't make guesses out of the dark. It's not a shot in the dark. We do some kind of an educated guess, and the educated guess here is that maybe we should just look for these simple ones where you have a function of x times function of t. So, and we are looking for non-trivial solutions that look like this. What's a trivial solution?
0.
0. 0 is a solution to this, isn't it? Right? 0 equals to 0. So we're looking for non-zero solutions that look like a function of x times function of t. Let's see how that works. Okay. Now, if indeed u is like that, what is u of t? This is u partial with respect to t. So you're differentiating by t. So what's that? f of x times g prime of t. Right? Because you're doing a partial with respect to t, so any function of x is considered as a constant, so you're only differentiating this function. That's the function of t, so it becomes g prime of t. Okay, now what about uxx? If you differentiate with respect to x twice, what would that become? F double prime of x times g of t. Okay. Now let's plug them back into this equation and let's see what our conclusion can be. That means you have f of x g prime of t equals to what? 3 times f double prime of x times g of t. Okay, so that's what we have. And at this point, it doesn't look like we achieved much. Yeah, you have a question?
No, you're good. Thank you.
Right. It doesn't look like we achieved much, but it will. We can draw some non-trivial conclusion once we divide both sides by fx times gt. So just divide both sides by fx times gt. So fx gt, fx gt. Now g prime and gt are different functions. Just like if you have t squared, if you differentiate, that's 2t, so that's totally different, right? Or if this is sine, there will be cosine. So these are totally different functions. You can't cancel them. However, f of x and f of x, what can you do? You can cancel. Then you can do the same thing here, right? You can cancel gt. Let me see. I have to think a little bit. Just a minute. You actually want to divide, including the coefficient. And whoever thought about this first was probably a genius. I think Joseph Fourier was the first person who realized that you can do such a calculation. So you get this, and then let's see, 3 also cancels, and that's what you get. Okay. Now, write down what you have and think really hard what this means. Okay, on the left side, you have a function of t. On the right side, you have a function of x. How can they be equal?
When x equals t?
No, x and t they're not related. X can be, see, here, x is the position, t is the time. So they're not totally unrelated. X can be 2, 3, 4, 5, anything. T could be 2, 3, 4, 5, anything.
Isn't the bar staying the same length, so wouldn't x just always be 2?
No, x is not the length, x is the position.
Okay.
Yeah, x is the position, t is the time.
So this thing is moving?
It's not moving. It's a bar that initially had this temperature and gradually becomes 0 because the endpoints are set to 0. The temperature distribution goes down. So at location x at time t, you have a value. Okay. Where uxt is given by the product of those two.
So the bar is getting smaller?
No, it's not. No. The temperature
is
on the bar is getting smaller.
So put 2 blocks of ice on
The
each side.
temperature.
Yeah, I know that, but the position, how is the position of it going to change?
No. X is between 0 to 2 because the length of the bar is. So what is uxt? Is the temperature at time t and at position x. So if I say t is 1 and x is 0.5, what does that mean? At time t equal to 1, after 1 second, at position 0.5, it reports back the temperature at that location. It's it's a function of two variables. You can't say what's the temperature at time t equals to 4. Doesn't make sense because at time t equals to 4, you don't have one temperature, you have a temperature distribution. Right? So the temperature distribution is a function of x, where x is the location. Does it make sense?
X is like the location of where you're going to put your thermometer on the bar to measure the
Oh,
temperature.
that's a wonderful way to say it. Thank you. Yeah. So x is the place where you're going to measure the temperature. T is the time when you measure.
The when and the where.
Yeah. So x can be anything, time can be anything, right? But going back to here, you're saying you have two functions. One side a function of t, and you have another function of x, and you're saying we have the result that these two should equal. How can that work? How can a function of t be same as a function of x? Yes.
1/3 is like your k.
No. What else? It's a constant. Okay. So see. All right. Is 3 a function? Just give me a random number. 11. Is 11 a function?
No.
If you view this number as a function, it is a function, right?
Okay, yeah.
Yeah. What kind of function is it? A constant function. It doesn't care what variable you put in. It always gives you back 11, right? Okay. Now, is this a function of t?
No.
Yes and no. You could think of this as a function of t.
No matter
It's just
what t is.
what t
it's
value
still
is, you get 11. Is this a function of x?
Yes.
Yeah, it is, right? Yeah. So, you have a function of t, you have a function of x. How can they be equal? If it's some number, then it's possible. So that's the amazing argument. The only way a function of x and function of t could equal is if it's equal to a constant. Okay. So now, however, instead of putting c for constant here, I'm going to put negative lambda. Okay. Now, why would I do that? That's because if you write this as negative lambda, then suddenly this part of the equation turns into something that we have solved before. So let's see what that is. Multiply fx both sides, and you get f double prime of x equals to negative lambda f of x. Move this to the other side, and you get f double prime of x plus lambda f of x equal to 0. Where did we do this before?
Count 3.
That's the eigenvalue, eigenvector, no, eigenvalue, eigenfunction problem, right? Yeah. But we can't just solve this. We need something more. What? We need to get the eigenfunction, eigenvalue. What do we need?
Two values.
The endpoints. We need the endpoints, right? So, in order to actually proceed more, we can't have just this. We need the endpoints. So we need the endpoints, and the endpoints. And now is the time to apply this. Okay. Now is the time to apply that, which is saying that what is u0t if uxt is this? So this one says, what's u0t if uxt is fx times gt? What is this equal to?
0.
F of 0, g of
0.
t, okay? And what is u2t? F of 2 times gt. And they both have to equal to 0, right? It says 0. Now you have two things multiplied to 0. What does that mean? If you have something and another thing multiplied to 0, what does that mean?
It's 0.
0.
At least one of them is 0. Okay, so we have two choices. gt could be 0 for all time, or f of 0 could be 0. Okay? Now which one should we choose?
GT 0.
Okay, if g of t is 0, what happens? What's u?
Never mind.
If gt is 0, what happens to u?
That would be 0.
It's 0 for all time, and even for all x, right? Is that good or bad? Because what do you call such a? It's a trivial solution, right? So if g of t is equal to 0, you get a trivial solution. Therefore, you want f of 0 to be 0 instead. Okay? So you need f of 0 to be 0. And again, because you want non-trivial, f of 2 should be 0. Because we want non-trivial solutions. Okay? Okay, that's good. Now put this in here. F of 0 is 0. F of 2 is 0 with this and you because you're trying to find those solutions which is non-trivial and that still satisfies this endpoint and the differential equation that limits what lambda could be, right? So we have to work all that out. So you have to solve this eigenvalue problem. Okay. Now because we have done it before and I don't want to spend time solving that eigenvalue problem, let's just move on. Oh, I don't want to erase this. Let's just move on and let's assume that we solved it. Actually, if you solve this, I know because endpoints is 0, I know it's sine n pi over 2 x. Okay, and these ones, if you plug in 0, you get sine 0 equals to 0. If you plug in 2 over 2 is 0. 2 over 2 cancels, and you get sine n pi, which is 0. So this perfectly matches everything, right? This one, and it should satisfy this. So I know that f of x is some constant times that. And in addition to this, what should lambda be? Lambda, if you differentiate this twice, you'll get n squared pi squared over 4, right? And for that to cancel this negative n squared pi squared over 4, so then it cancels. So for these two to cancel, lambda has to equal to this value squared. Lambda should be n squared pi squared over 4, because or else you can't cancel. So just imagine yourself plugging this in here. If you differentiate twice, this will pop up. And if you plug it in here, it's the same thing as it matches with this being negative, that will be positive. So when lambda is this value, then they're going to cancel and you're going to get 0. Okay, so if we had the time, I would actually go through all the solutions, but we will skip this. And it's similar to what we did before, so just accept this as the solution. Now let's see. Now what do? We got the value lambda. We found the function. That means we actually know what this is. Now we have to find gt. How do you find gt? G prime of t, if you multiply this to the other side, it's negative 3 lambda gt. Okay, if you move it this way, you get g prime of t plus 3 lambda t, but lambda is n squared pi squared over 4 gt. Okay, I think I know how to solve this. How do you solve this? Characteristic equation, right? It's a homogeneous first order constant coefficient differential equation. So you just say r plus 3n squared pi squared over 4 equal to 0. That gives you r equals to negative 3n squared pi squared over 4. And that goes into the exponential function, right? So that we get g of t as some constant c1 times e to the negative 3n squared pi squared over 4t. That's your g of t. I'm just doing what we were doing for the second order differential equation. Usually you write down the characteristic equation, you solve it, but I'm doing that for first order. Any questions so far? I mean, if you didn't understand this, think about how you would solve y prime plus 3y equals to 0. you would put r plus 3 equal to 0, r is negative 3, and wouldn't you put c1 e to the negative 3t? That's what you would do, right? Yeah. The only complication here is that instead of y, I have g prime and g. And instead of r equals to negative 3, I have negative 3 times some crazy thing. So it's, I mean, these two things are something that we've been doing before. The only difference is numbers are slightly crazy. Okay? Okay, if you're okay with this, now we can go back and plug in everything back to U and get our solution, right? So let's erase everything. And try to appreciate the very first step into the partial differential equation, because we just found out one solution to this heat equation, and that heat equation is fx c times sine n pi over 2 x times this function, but this c we can ignore because there's a c1 times c, it's nothing, right? So another constant. So we can absorb this c1 into c and just say e to the negative 3 n squared pi squared over 4 t. So that's what we get from here. Okay. By the way, such a method is called separation of variables method. Separation of variables. Yeah, it acquires that name because I'm assuming that uxt is a function of x times a function of t. So that's where that name comes from. All right? Any questions until here? All right? Now what do we do? We found one special solution, assuming that it looks like this form. What do we do afterwards? What do we do afterwards?
Solve for C.
No, it's not general enough. It's just one solution. What do we do?
Do we plug in points we were given?
No, in second order, for example, if we had y double prime minus 3y prime plus 2y equals to 0, and we did, don't write this down, I'm trying to explain. This one has r equals to 1 and 2, right? So we get one solution, e to the x and e to 2x. What do we do afterwards if we get these solutions? We add them up. We take superpositions, right? Yeah. See, is this one solution or many solutions? This is actually many solutions because what's the value of n? N is any positive integer, right? So this actually is infinitely many solutions, right? So what should we do?
Sigma.
We put sigmas. So we do uxt equals to cn, sigma n from 1 through infinity, cn sine n pi over 2 x e to the negative 3n squared pi squared over 4t. And I claim that this is the most generic solution to this. Yeah. And you may have noticed that not only, actually it's not the generic solution to this, we also use this one, right? So if you have this along with this, that's the most generic solution. Okay? And then the only thing that we didn't put into play is our initial condition. So we have to think about how to put the initial condition. Okay, let's